Welcome to qnawire.
First, I would recommend making a triangle to represent the scenario. So we've got a side length 16.7, 8.3, 9.1. Angle F would have to be side F, which is the 8.3. If side E is 9.1, then angle E is opposite. And then angle G would have to be opposite side G of 16.7. Because we don't have an angle and opposite side pair, this is the side-side case of the law of cosines. The law of cosines generically, because we have a side squared equals the sum of the squares of the other two sides minus 2 times those two sides times the cosine of the angle. It begins and ends with an angle opposite side pair, side angle. So if you want to find angle F, you're going to put 8.3 side F into the formula. So 8.3 squared equals the other two sides are 9.1 and 16.7. So 9.1 squared plus 16.7 squared minus 2 times 19.1 times 16.7 times the cosine of angle F. Then we would subtract the 9.1 squared, subtract the 16.7 squared. We got to solve for F, so we have to get rid of each of these terms. And then we've got negative 2 times 9.1 times 16.7 times cosine F. We want to divide that as a whole term. Negative 2 times 9.1 times 16.7. Now we're left with just cosine of angle F. Now you want to find angle F, we have to undo the cosine. That's called the inverse cosine of both sides. It gets rid of it on the right. We have to take the inverse cosine of all that on the left. If you're doing this with a handheld, I would recommend doing this in stages. Do the numerator, hit enter, divide by, with parentheses here, the denominator. And once you have that, then inverse cosine that answer. I'm going to show you this on Desmos. So if we do 8.3 squared minus 9.1 squared minus 16.7 squared, and then we will divide this by negative 2 times 9.1 times 16.7, and we want to inverse cosine this whole thing. Now you'll want to make sure whatever calculator you're in is in degree mode. Okay, and now the inverse cosine, you go to functions, of that whole thing to the nearest degree is about 16 degrees to the nearest whole degree. Hope that helps. Good luck.